Alright, what's up you guys? It is Sunday, it's about a little after 10. I'm about to do some soldering. I have two analog to digital converter types, models, different chips I guess you could say. First one was an ADS 1115. This other one is an MCP or MPC something. I don't know. If I remember, I'll put it on the screen, but I think I soldered the ADS ADC. So like the little pins that go through the vias into the header on the ADS, I think I soldered it in backwards because then both sides were too short to push into a little breadboard and then too short on the other side to snugly secure jumper wires onto. So my ADS would not connect to my Raspberry Pi for whatever reason. And so I'm like, okay, I still have the other model, which has this MPC is like a narrower voltage range that it can be reading out. So I won't get into the details yet of the thing that I'm building. That's for another video, but let's look at my soldering setup here in my kitchen. Alright, I had to figure out how to lock the gimbal on this bad boy, this new camera that I've got. Anyways, so here it is. It's MPC, MCP, whatever, but I don't know if you can really tell, but the pins are now barely extending over the surface of the board. So I can even go grab the other one. Okay, here's the other one. Suboptimal lighting. I don't know if this is going to focus. Probably not. But, and you can barely see this. Maybe I need to grab a magnifying glass. Hold on. Okay, so magnifying glass doesn't really help, but I've done soldering over many moons, and the solder job that I did is totally fine, but the problem is, you can't really tell from this angle, but this does not push into the board, so half of the pins, well, all of the pins, but I mean a half length is extending below the board and then above the board, whereas I need to have it where the majority of the pin length goes below the board so that I could press this chip into the breadboard here, and then I could connect wires on the different rows. I was just kind of not really thinking, and I was like, oh, I'm gonna attach the jumper wires straight up on here, but then it's like, well, maybe I need to put some resistors, cut the voltage a little bit, or like maybe some diodes so I don't accidentally like blow out my Raspberry Pi here. So maybe I should just pick this up. Yeah, as you can see here, so this is like fastened, or not fastened, it's pressed into the board, and it's not falling out, and there is a little bit of pin sticking out, so I'm going to solder that on here. This magnifying doesn't really help, but shout out in the comments, drop a comment if you know where I first used this magnifying glass. You're a real one, but I don't know, maybe we'll just cut to a time lapse of soldering here once my iron warms up. So yeah. Alright, so I don't know if you could glean from the time lapse, but I sort of started off, I'm going to turn off my iron. Started off kind of slow, didn't really get in the flow of things and be on my soldering roll until a few pins in. but I feel like I did a half decent job. I would give myself a B minus for my solder job, so let's take a look. All right, so difficult to see, but everything is at least not touching another pin. And then I guess if I move it to the side here, I guess my big criticism is that my amount of solder per pin is not very regular, and it's kind of just like a ball on top. Yeah, super hard to see here. But I mean, as long as there isn't any cracking and it's a good connection, I feel like this should work. And I wasn't slopping around with the soldering irons, so I wasn't like just, hitting the board with the tip of the iron. So I feel like I did an all right job. So I don't know, I'm going to wait for this to dry. As you may have seen in the time lapse, I did like a little cup with some flux of just like room temperature tap water, and then I twirled it around with my finger. Really what I was trying to emulate there is like, ideally if this were like a fully set up lab, I'd have like a little crock pot with some warm water with some flux dissolved in it, and then you can dip your board in after, and it makes cleaning up the excess flux easier. It just gives it that professional touch, I feel like. So I don't know, I'm just gonna wait for this to like fully dry out, because I'm not gonna obviously like plug this in right away. I mean, it's dry now, but it's like, I'm gonna give it just for safe measure, some time to like air dry out, plug it into the Raspberry Pi. Hopefully it's all good. I don't know, see you guys in the next clip. Who knows what's gonna happen. All right, you guys, it is now a little past 4. I've been tinkering away with this. I think I finally have the essential parts of my coil winding jig built. I'm being tacked by my son, who is a Black Panther super predator. He just had his dinner, and now he wants to eat me for dessert in a vicious attack manner. So I'm going to show you guys how this works. All right, so I have, this is, like I said, not the fully built jig, but it's the crucial parts, right? So I have these books stacked up so that the Hall sensor underneath here is really close to when the magnet spins by, which this is an adapter that I glued onto a PVC cap, and then this is a segment of pipe which I'm going to be wrapping the coil around. So when I squeeze the trigger here, we can see that the magnet spins pretty nearby the sensor, and it's going to be difficult for me to get the shot. You're just going to have to listen to the drill. Yeah, this is super janky. Oh, I should also say, the way I'm doing this is, okay, I have a Hall sensor which is connected to that purple, that's the MCP ADC. MCP is like the brand, model name, whatever, but it's an ADC, so an analog to digital converter. That's what I was soldering earlier. Then we have that connected to the GPIO pins on a Raspberry Pi, which is connected via Ethernet to a router, which I don't pay for internet in my apartment because I'm basically the Unabomber, I guess. Don't quote me on that. But then, so Raspberry Pi over Ethernet to the router, Ethernet to the laptop. So the router is just basically acting like a switch. And my cat is, as usual, getting his cat butt in the way. Okay, level out the gimbal here. Let's see if I can't make this just like super big. So I'm going to, all right, so it's running and it's looking at the Hall voltage. Hall sensor voltage. So hopefully now this is going to start counting. And then I stop. And I wish I could, I don't know, maybe I would do like an overlay with like my phone right now if I weren't lazy, but now I'll do it a little more. So at the end there, I went pretty fast, and so the transients are too fast for the threshold voltage to be counted for the actual physical number of winds, but that's the point that I've gotten it to so far today. So yeah, I'm like doing my laundry right now and having problems with the app, and it makes me and my Unabomber self wish we could go back to a time without needing so many points of technology in order to do something like get your laundry done. And I'll probably have to haul my laundry over to a laundromat to use coins, quarters to dry it off. Because I was like trying to add money, and then the app was just not having it. So, but at least in theory, I could be winding my coils with an exact count now, as long as I keep the drill speed low. But if I like squeeze a little bit too hard, then my count will be a little bit off. But anyways, that's just a little update this afternoon. So I'm gonna go finish my laundry. All right, back again with another update, you guys. I just recently finished using my DIY coil winding drill jig. So to recap, I have my stack here of books so that my drill would be positioned right above the Hall sensor that I taped onto Bean and Time by Martin Heidegger. And then the output from the Hall sensor is going into this MCP analog to digital converter, and then I had to make a little voltage splitter, I guess, because the induced voltage purely from the magnet and the Hall sensor was a little bit high outside of the range of the ADC. So really all I wanted to capture was just like a transient signal for when the magnet spun past the Hall sensor. Hopefully I've edited in last weekend's iteration, but then this morning I was able to successfully use that to wind this coil here, which has approximately, but pretty sure that it's exactly 100 coils, because my wind count on the computer said 100, but it started at 1 because I had the magnet directly over the Hall sensor. So really it only wound 99. But then I had 3 extra winds to start off, and then I unwound 2 of those so that I could get the leads coming off of here. So yeah, it's 100. And then it's maybe hard to tell, but I was trying to not just crank the drill, so the winds weren't like make one perfect layer and then another perfect layer on top. Like there are some parts where there's maybe approximately like 3 or 4 coils underneath or thick around the PVC pipe. And then there are some that may only have 3, or like at the very edge, there's only like 2 or 1. But kind of my goal was to keep the coil fairly narrow and to approximately match the cylindrical height of this neodymium magnet here, which now I've hot glued that onto my plexiglass giant protractor arm. And one of my relatively recent modifications was how I'm actually mounting this stepper motor, and it's my main concern at this point because, for one, okay, this like ruler component of the plexiglass attachment, the stepper motor axle is not an exact cylinder. Maybe you can see there's a little bit of a flat part there. So it's not 100% flush, even though I drilled I'm calling this straight part the ruler attachment, and then I have the protractor, like there's a wing nut, bolt, whatever, to like secure the two ends of this protractor arm around it. But so I had to hot glue and have these collars on the stepper motor, but as a result, this ruler part is basically attached for now, like just stuck on this motor. Like I'm not able to like take it off so that I can unscrew the wing nuts so I can slide the coil on here. This ruler part has to stay fixed to the motor. But the problem is that I want to get this to oscillate back and forth between some, let's say like a positive angle, and then that same angle but in the negative direction. So like right now, if it's at 0, maybe I want it to go like 30 degrees clockwise and then swing 60 degrees counterclockwise, go back to the other, negative 30 degree position and go back and forth so that the magnet swings through here, right? But this stepper motor, when I've been using it so far, it doesn't have a perfectly smooth action when I do that. So originally, had to put my lav mic actually on instead of William, but I had this right here. This, I think it's called a burette clamp because there's this cork lining inside of it, and so you could stick like a test tube in it, and then you would attach it to this retort clamp stand that I have here. But the problem is that I have this mount right here that's screwed onto the stepper motor. This would be extending and it would kind of like sag a little bit, and this would be extended out a little bit. So there was a considerable amount of torque, and this would just kind of like not stay in the same position the whole time. It would kind of like swing back and forth as the motor would move, and then it would also rotate in this direction because there's this lever arm introduced, right? Because the motor would be essentially farther away from where the stand is. So got a few more parts in the last few weeks so that the motor is more secure and then it's closer to the axis of the retort stand here. So right now the coil sits where I'm assuming that this magnet is going to be able to freely just oscillate in and out of here. But there might be still a little bit of wiggling, shaking. I'm not really sure yet. Also, the coil that I made just now might be a little bit too narrow. So I might have to wind another coil that's just a little bit larger. But now that I have the coil winding jig, it's like super easy. Made a nice little Python script so that I could, count exactly. And it doesn't take forever where I'm like winding and holding it with two hands. And so the coils are, it's really tight and didn't take a lot of time, super easy. So yeah, the next step is going to be, I guess, powering on the stepper motor, which I already know, I've got the script for the Raspberry Pi to drive it. I know the motor works. I know I can get it to do that back and forth, right? Because I had it attached before with the cork lined, not flat jaw burette clamp or whatever. So like my main concern now is just making sure that like the coil does not get knocked off when the motor is running, and that's like the end of the dry fit, I'll call it. And so I've got all the components I need, all the wires are long enough and in place. Oh, the other thing is that I also 3D printed this attachment on the back. So in here, there is a magnetic angle encoder. So I put a tiny magnet that came with it on the axle of the stepper motor, and then that is directly above, I guess probably another hall sensor, but maybe like a locking one or whatever, and it's already good to go hardware wise, so that I can now read out into the Raspberry Pi the angle that the motor is at any particular time. So I'm able to program in and say, maybe I only want the motor to turn between a specific angle, but then more importantly, I'm going to have a readout of the angle. So the three readouts that I'm going to get from all of this are: one, the angle that the motor is at any particular moment in time; two, the induced current due to the action of the magnet swinging through the coil. And then I guess this isn't like totally done for the dry fit, but I got this hall sensor here. There was like a bag of 10. I'm going to put another one inside the coil so that I can have a readout of the magnetic field that's inside the coil as the magnet is swinging through. So in principle, when I have those three readouts, angle, induced current, magnetic field, those should all more or less agree, especially in the time aspect. And it's Faraday induction. So I don't know, that's the current state of affairs with this. So it's Martin Luther King Jr. weekend. So, but anyways, no work technically on Monday. I might go in for like 4 hours over the weekend, or even go in still on Monday, just because I have a lot of stuff that I not necessarily have to work. There's things I have to work on, but there's stuff that I just started. I'm trying to like really kill it at my job right now, and just like, I'm 31 years old. I'm trying to like really mean it when I say I'm hitting the stride of my career. So you don't do that just by kind of like sitting around just being like, I'm like doing all this stuff. It's like you have to get the work done too. And so it's like, you know what? I don't have, what else am I going to do? What else do I have going on? So yeah, that's my little update.